Abbey Road's implementation of ADT had a couple of specific elements that contributed significantly to its characteristic quality, which sounded so good on all those old recordings, and still stands out even nowadays as a particularly human, organic doubling effect. I'll describe the hookup and process in detail. Since it's all recreated in the real ADT plugin, knowing how it was originally done is very helpful in understanding the specific features, especially the less common ones that you'll come across in the plugin. If you're not a tape maven, it might seem a little complicated, so bear with me. So, first a little background. Creating a doubling of a pre-recorded track artificially involves duplicating the track signal, delaying it slightly, and mixing the delayed version back in with the original to simulate the natural timing variations you'd get if two players were performing the same part together. Before there were delay effects, even analog delay effects, this required a second tape machine to process a copy of the track. Okay, now for you guys who came up in the digital era, a quick review. Multi-track tape recorders have three heads. There's the erase head, the record sync head, and the playback head. On a multi-track tape machine, each head is really a head stack, containing a separate head for each track. So on a J37, for example, the record head is really four heads, one for each channel, and the functions of each channel's head can be switched independently. More on that in a minute. The tape is pulled past the heads, or head stacks, in the order I listed them, as you can see in the graphic. Their functions are mostly self-explanatory. During recording, the record head puts the signal onto tape, and the playback head reads the newly recorded signal off tape a few milliseconds later, based on the tape speed and the gap, the distance, between the record and playback heads. If you were going to overdub a track, record a new performance on, say, track 3, while listening to previously recorded tracks 1 and 2, you'd put tracks 1 and 2 into playback mode and track 3 into record mode. But if you played along with tracks 1 and 2, which were coming from the track 1 and 2 playback heads, and your new performance was recorded onto the tape via the track 3 record head, the new track 3 would be out of sync. If you record a note to track 3 at, say, bar 5, the new note will be here on the tape, at the position of the record head. But the notes at bar 5 on tracks 1 and 2 that you played along with would be here, at the position of the playback head. So in this situation, to keep overdubbed parts in sync, the record heads for track 1 and 2 would be pressed into service for playback, instead of using the track 1 and 2 playback heads. This is why the record heads are really record sync heads, since they have this dual function. In theory, the sound quality from the playback heads is superior, since they've been optimized for playback rather than recording, but on really high-end tape machines, the difference is not that much. Each track has an output amplifier, and each track can be switched to output from either the playback heads, like for mixing, or the record sync heads, for overdubbing. Now, how does this relate to tape doubling? Well, to artificially double a track, you need to feed a copy of the signal from a track to a second tape machine and delay it. But if you were to get that copy by multing or duplicating a track from the first machine's playback head, the timing difference between the original and the copy would be too great for doubling. Instead, you'd have an echo. Check out the chapter on the J37's echo effects for more on that. Now here's where the Abbey Road method comes in. Kent Townsend took advantage of two specific features of Abbey Road's J37s. While most multi-track tape machines have one output per channel, switchable between the playback and sync heads, the J37 had two outputs per channel, so a track signal was available simultaneously from both heads. Townsend took the main signal from the first machine's playback head, and then took a duplicate from the record sync head and fed that one into the second J37, the ADT machine. The second machine was in record mode, so the copy was recorded and immediately played back via the second machine's playback head. The copy, fed from the sync head, would be ahead of the main signal, but the delay from the second machine's record head to its playback head put it back into perfect sync with the original signal. Well, almost perfect sync. This is analog, remember? Now, that's the first component of the Abbey Road method. The second is that Abbey Road had modded their J37s to allow for external control of the tape speed via an external VCO, an oscillator, controlling the motors. This is called vari-speed. The VCO, in turn, was controlled by a handheld remote, which allowed an engineer to manually adjust tape speed on the fly. This was done to vary the timing, and concurrently the pitch, of the second ADT machine on the fly. The engineer manning the remote would vary the speed back and forth enough to produce the proper short delays to make that second signal sound like a double performance, and the fact that he was doing it manually on the fly lent a natural human quality to the timing variations. Depending upon both the initial speed set for the ADT machine and the amount and quality of the manual modulation, they could get anything from a highly natural doubling to deep phasing and flanging effects. This was the secret to the Abbey Road version of ADT, and all the elements of this method are recreated in the real ADT plugin. So let's take a look at it. Next up, I'll start going through the controls.